Hi everyone, and welcome back to my channel A in Economist. Thanks for joining me in this video. So this is going to be a continuation of our previous lecture where we have studied how to use maximum likelihood estimation method in order to estimate the parameters of an AR1 process, right? So we have already done how to use maximum likelihood method to calculate the parameter of AR1 process. Now we will, generalize the thing and we will see how to do this for an ARP process, right? ARP process, again, I have taught you in a separate video. If you haven't watched that video, I'll give the link in the description so you can check that out. So let us start with the general form of the ARP process, which is alpha plus phi1 yt minus 1 plus phi2 yt minus 2, and this will go on up till pi p yt minus p plus epsilon t, right? Now this epsilon t follows IID. Now instead of taking white noise, I am assuming it to be normal. So this is basically Gaussian ARP process. Gaussian ARP process. Gaussian means that simply epsilon t's are following normal distribution instead of taking white noise. So when I taught you ARP process, I have told you that epsilon t's are white noise, following white noise. And white noise is not, specifically any process, right? White noise is a general thing. Whenever the mean is 0 and the variance is some constant term, you call that process to be white noise. So, but not any distributional assumption is made. So when I say that it is normal, it means that I am making a stronger assumption. I am taking a stronger assumption in my calculation and I am calling this distribution to be the Gaussian ARP process. Gaussian means that simply epsilon t's are following normal, right? Okay. Now, suppose again, what I have told you in case of AR1 process is that we have to assume that we have taken out a data set y1, y2 up to yn from this specific process, right? We are assuming the data set to be y1, y2 up to yn, which is again of size n. A data set, a time series data set of size n from this ARP process. So in the previous video, let's recap a little bit. So I have started with this data set and I told you that this data set is taken from this process, AR1 process, right? So in Python also, if you want to do this, you can simulate and find out the data set. What will be a random data set from this distribution? So generating samples. So it is known as the sample generation method. So in the similar way, in Python, you can also do this. In case of ARP process, you can find out a sample data set drawn from this particular distribution of YT, which follows ARP, right? Now, what is our job? Our job is to find out the parameters, right? Estimated value of the parameters. So what are the parameters here? Here, if you see, the explicit parameters are alpha, phi1, phi2, up to phi p. And again, we have an implicit parameter in terms of sigma square, right? So these are all the explicit parameters. And this is an implicit parameter. If you haven't seen my previous video, please do that. There I have explained what are these parameters, right? Okay. So we want to basically find out the estimation for these parameters. How many parameters are here? If you see phi1 to phi p, p parameters, and then here you have one parameter and here you have one parameter. So p plus 2 parameters are there, right? Your model, ARP model has p plus 2 parameters and we want to find out what will be the estimated value of these parameters. So let's start with that. Firstly, we will again start with the likelihood function. We will start with the likelihood function. So what will that be? Let us understand that. So L theta curve. So this is simply f of y1, y2, yn, which is simply f of y1, f of y2 given y1. This is the same as I have, told you in the previous video. So I'm not explaining this once again. F of yn given yn minus 1, yn minus 2 up to basically y1, right? So this is the likelihood function of the conditional likelihood function. Now the next step is a little different. Here what you have to do, so understand this thing that here you have 1 to n data points, right? What you have to do, you have to separate out the first p data points. Remember, we are dealing with ARP process. There are p, explicit variables, y t minus 1, y t minus 2 up to y t minus p. So firstly, separate out the first two p variables and then consider from p plus 1 to n. So see what is the process here. If of, firstly write yp minus 1 up till y1, and then write the rest of the things. Y of yp plus 1 given yp minus 1 up to y1, and then write f of yp plus 2 given yp plus 1, yp, y1, and in the same way it goes up to yn given yn minus 1, yn minus 2 up to y1. So this thing is a little different of what we have done in case of, white noise, in case of AR1 process. So this is what you need to understand. Firstly, separate out 1 to p. So I have written the joint distribution of that. So that can be written as y1, y2, yp, right? If you arrange this, take this to the last term and this to the first term. So f of y1, y2, yp. So this is the joint distribution of the variables from y1 to yp. So when I say 1 to p, it means y1 to yp basically, right? You have altogether y1 to yn, this n variables or this n values or data points, whatever you call it. Firstly, take the joint distribution of y1 to yp and then write everything else as the product form. So f of, what will this be? This will be yt given yt minus 1, yt minus 2, yt minus p. And now what will be the range of t? If you look carefully, your t is p plus 1. So it will start from p plus 1 and it ends with n. So it will end to n. Right? I hope this is clear. This is the only thing that you need to, carefully do here. Everything else is the same. The writing the likelihood function is the most important thing. Rest of the things are absolutely the same as we have done for AR1. Okay. Now, why we have done this? Understand this, that this is something which is very difficult to find. This expression is very difficult to find, right? We cannot simply find out what will be this expression, this joint distribution. But we can simply find out this, the second expression, right? We have, separate these things out because this is something which is very difficult to find and it will, come out with a very messy expression. And it's very difficult to find this out. But what we know is that this is something very easy to find out. So what we do here is that we will find out something called the approximate likelihood function. Approximate likelihood function. So in case of AR1, we have found out the exact likelihood function. Exact means each and every term, the explicit form of each and every term, right? So let me go back and see what we have done here. Yes, so this was the likelihood function in case of AR1 process. And we told that we explicitly know what is f of y1. We found that out, what is the marginal of f y1. Then we have calculated this expression, and this expression, and everything in between. So we told that we know each and every term of this expression. So the likelihood, what you get from here was the exact likelihood function. Exact likelihood function, because you know each and every term of the likelihood function. But here what I'm saying is that the first portion of this likelihood function is difficult to find. So what we can do, we can simply drop this, right? What we do, we simply drop this as of now and we will focus on only this thing. And we will say our likelihood function is approximately equals to this second expression. right? We will say our likelihood function is approximately equivalent to this second portion of this expression, what we can explicitly find out. And the estimates that we will get here will be the, conditional estimate, right? Conditional estimates or approximate estimates, and that is what is enough for us. We don't need the exact estimates all the time because sometimes it is very difficult to find out. So what we need to know, we need to only find out the approximate estimates, and that is what we will do here uh, using the approximate likelihood function. So basically, I'm saying that this will be equal to or equivalent to, not equal to, this will be equivalent to the product over t from p plus 1 to n f of yt given yt minus 1 up to yt minus p. This is the same thing as we have written here, right? In the second term. Okay. If you understood this, now our only job is to find out what will be this distribution. Again, we have to find out the expectation and the variance and then see what will be this yt minus 1 up to yt minus p. This is what we need to find out now, right? Okay. So again, do the same thing, find out the expected value. So for that, check out the distribution. So here you have given values are yt minus 1, yt minus 2, yt minus p. So expectation will be only on the epsilon t. So expectation of epsilon t given all these yt's, given all these yt's will be what? That will be 0. So what you will be left with? You will be left with alpha, the first portion, which is the constant portion, right? So let me write yt, yt minus p. And that is what will be the expected value. So in general, what you can write summation. No, firstly you have alpha, write that first, alpha plus summation phi j yt minus j, and this j from vary from 1 to p, right? J will vary from 1 to p, and this is what you will have. And then find out what is variance. Pretty simple. Yt minus 1 up to yt minus p. So that will be simply variance of epsilon t, and that is simply sigma square, right? So this is the variance and this is the expectation. And again, I have told you, if you know the expectation and the variance, you can simply find out what will be the PDF, the distribution. So let me write this yt given yt minus 1 up to yt minus p will be in distribution, normal. Again, normal because we are taking Gaussian ARP process. In AR1 process also, I have used Gaussian AR1 process. I, forgot to tell you that, but I hope you understand that this is normal. Normal means Gaussian ARP process, right? Okay. Alpha plus summation. This is 1 to p phi j yt minus j, and then you have variance is sigma square. So what will be the PDF? Yt minus 1, yt minus 2, yt minus p. That will be what? 1 by sigma root 2 pi e to the power minus half yt minus the expectation j from 1 to p. If you have seen my AR1 video, then you will find this pretty simple, I hope. This is the same thing I am doing again and again. So now what will be the t? Range of t? Range of t will be coming from this, right? Range of t will be this. So we have literally dropped this first portion. We are not working with this portion. We are only concerned with this second portion. So the range of t will be coming from this. T is from p plus 1 to n. So it is p plus 1 to n, right? So we have got this. This is the second portion of the likelihood function. Now likelihood function will be what? It will be simply approximate. This is important to write is as approximate. product over t from p plus 1 to n, as I have told you, f of yt given yt minus 1 to yt minus p, where f of yt given yt minus 1 to yt minus p is the expression we derived earlier. So this is the expression. This we just derived, right? This is the total PDF. So if you see, they are in terms of parameters and only y values. Parameter values and the y values. So this is the expression of the PDF. And now again what you have to do. So this is the approximate likelihood function, right? Approximate. This is the approximate likelihood function, or what we call the conditional likelihood function. And step 2 is simply maximize. Maximize this likelihood function with respect to the parameters, right? What are the parameters? Parameters are everything that I have told you here. These are the parameters. So this is the vector. Parameter vector is this. Alpha, you have phi 1, phi 2, phi p, sigma square. So altogether you have p plus 2 parameters. So if you maximize, you will have p plus 2 normal equations, p plus 2 normal equations, and p plus 2 unknown parameters, right? P plus 2 unknown parameters, and then if you solve, you will get the estimated value. So estimated, we will get the estimated value of alpha cap MLE. You will get phi cap j MLE, where j is from 1 to p, and also you will get sigma square cap square MLE. Right? The process is exactly the same. Let me tell you once again what I have done here. The only difference is lying in finding the likelihood function. The writing the exact form of the likelihood function, everything else is the same. So start with the MLE. For ARP process, start with the process itself, write the process down, and then assume that you have taken out a sample of size n from this particular, process, or whatever process you are working with. Then find out what are the parameters, unknown parameters in the model. Once you have that, you can write down the likelihood function in this form. Now, only thing different here is that since we are working with ARP process, you have to find out the joint distribution. You have to separate out the joint distribution of y1 to yp, but that is very difficult to find out. Hence, you can drop that out safely, saying that we will find out the approximate likelihood function instead of exact likelihood function. And the rest of the things are written in this fashion. And then what you have to do, simply calculate what will be this PDF, right? This PDF can be calculated using the mean and the variance of this particular expression that we have found out, and then that will help us to write the PDF, right? Once you have the PDF, you have the approximate likelihood function. Approximate likelihood function is simply the product of this PDF over t from p plus 1 to n, and that will give you your exact form of the, not exact form, the approximate likelihood function in terms of this. And simply in step 2, you have to maximize. Maximizing involves the same thing, that take the partial derivatives with respect to the parameters and set them equals to 0. That will simply give you your normal equation. And once you solve those equations, you will have the estimated value of this. And this is, a very, messy process actually. So I am not doing this explicitly, but I have given you the approach, the process. Once you know this, I want you to do a little homework. Homework is that find the maximum likelihood estimator for AR2 process, right? I have given you what will be the estimates for AR1 process, and I have also told you what will be in the general form ARP process. Now find out what will be the MLE estimators of parameters of AR2 process, and let me know what you get in the comment section. And if you find any doubts, any questions anywhere, you can also post that as a comment below, and I'll be replying to them. So thank you for your time, and I hope you find this video helpful. If you do, please like, share, and subscribe to this channel, and that will help me to grow this channel. And thank you for your time. And until next time, in the next video, I'll be going into the MLE estimation of the moving average processes and ARMA processes later on. So stay tuned for that. Thank you for your time.